Hello all. So in this video we are going to see about the turn-off process in Power BJT. So in normal BJT, the turn-off process is going to be the similar than that is that of Power BJT. And since the normal BJTs, the conventional BJTs will be having the charges which are stored inside the junctions of the device is going to be very much smaller, so the turn off process may not be going to be a complex one. But in Power BJT, since the charges which are stored inside the device will be having 2 to 3 layers to be crossed, so that the turn off process is going to be complex in case of Power BJT. So in this slide, we have many characteristics have been drawn. So here, this is going to be the turn off characteristics. So here we have segregated the characteristics into 5 categories, like off state, turn on state, and turn off. And we have drawn the characteristics for VCE, IC, and IB. Since this is going to be the circuit when we are giving the gate pulse for the base with respect to the ground. So at first, if the IB current is going to be increased for some moment, so if the IB current is going to be increased on this direction, the IC current will be flowing by this direction, so that the IC current will be increasing the charges in the transistor. Since it is going to be the BJT, we will be having some of the charge versus VCE and charge versus IC characteristics, which will be given in the data sheet of the device. Here, if you notice that the three charges are going to be the significant charges that are going to constitute in the transition of the device characteristics from off to on or on to off. That are the charge across the collector and base, charge across the collector and emitter, and the charges on the QB. Since these charges are going to be built up whenever the IB is going to be getting increased, so that the the voltage across the VBE is going to be getting increased. Since this is going to be the constant voltage, for silicon it is going to be 0.7 volts. Since this is going to be the constant voltage, since we are increasing the VCE, and we will be having the IC to be increased. So since IC is going to be increased, at first the the QCB charges will be getting accumulated, and afterwards the QCE and the QB charges are going to be accumulated. It is for the turn on process. So since the turn on process is going to be constituted, the VC is going to be decreased. Since the VC is going to be decreased, the charges which are going to be accumulated in constant process, that the QB will be accumulated in constant, and QCE will be accumulated in some sloped manner. But QCB will be accumulated inside the capacitors of the particular power BJT. The QCB will be getting charged rapidly across the VCE's decrease. So the decrease in VCE will be getting this charge to be accumulated. So that is going to be this explanation of this particular graph. Since it is going to be the turn off process, we need to first look ahead with the normal operation. So the IC will be existing in the device till the QB will be existing. So if we remove all the QB across this device, then will be IC is uh, going to be reduced, or it will be nullified. So when the IC is flowing, the collector resistance, since the collector portion of the power BJT will be such larger, that is the substrate which is going to be the mainly constituting the collector surface will be somewhat larger, and also in the power BJT comparing to the normal BJT, the power BJT will be having the collector drift area too. So since if you're accumulating these two regions, the collector region will be getting very much extended portion to be covered. So since it is going to be the case, when the IC is going to be flown inside the device, the collector resistance is going to be reduced enormously. Since that is going to be the case, the VCE will be getting reduced very enormously, so that the QCB, the buildup of the QCB and the QB and QCE in continuation, that particular accumulation of the charges will be getting very high. So in order to switch off the device, the turn off process will be started when we are giving the IB is going to be negative. So the first thing, IB should be negative. So if you are giving the negative IB current, which is shown here, if you are giving the negative IB current, the negative IB current will be giving the QCB charges are going to be first removed, because these are only first charges that are going to constitute the charges accumulation in the device very rapidly. So the removal of the QCB will be getting very faster in case of the turn off process. So this is going to be the first step which is going to be constituted. Since QCB is going to be removed at first, since the QCB will be getting reduced, the QB and QCE will also be going to be started to decrease. So at first the QCB will be decreased. So the QCB is the charges which are constituted underneath of the base on the underneath of the base on the collector area. So these charges are going to be constituted across this particular device, and they will be removed across this BE due to the negative current in the device. So that is going to be the first step. Since the QB has not been decreased at this stage at fully, and QCE is not been decreased at fully, the IC will not be 0. So IC is still be flown. Since the IC is going to be decreased as comparing to this first step, since IC has been decreased, we know that the function of the particular BJT will be given as we can say that IC is going to be the function of so IC is going to be the function of IB and VC. Since IC is going to be decreased, the VCE will be getting increased. So how much the amount of IC will be decreasing, since IB is going to be decreased, VCE will be getting increased as linear characteristics. since this device having the early effect into that particular consideration, the amount of VCE which is getting increased will be enormous when this IC and the IB is going to be in the negative directions. Since the VCE is going to be increased, since this is going to be the case, then the QCE will be getting decreased, but the current density across this device on the uh, base and the collector side will be getting enormous. Since we are having the VC is going to be increased, the current density across the device will be getting increased due to the presence of this particular QCE. Since this current density is going to be decreased, the VBE will be getting negative, because since we know the VCB will be equivalent to VCE minus VBE, at the on position this particular voltage will be constant. But if we are getting this particular device into the off state, that off state will be decreasing this particular IC value, and this VCE will be getting increased. Since this VC is going to be increased, this particular VCB will be on the forward bias at the normal operation. So since the off operation of the device has been started, this balance will be getting disturbed. So this VBE will be going into the negative, as this VCB is going to be decreased. So since this is increasing, but this particular VBE should be negative in order to maintaining this particular voltage. So the VBE will be getting reduced. Since this VBE will be going into more negative, since this VBE going to be more negative, then the IE will be getting into the negative direction. Since this is going to be the case, then the particular IE will be reduced into the particular emitter section into the charges to be removed. So the charges will be getting pulled up. So this, since this charge is getting pulled up, the particular area which is covered by this particular emitter, the charges area covered by this emitter will be getting reduced. So the QCE and the QB charges will be getting reduced upon the uh, area of this particular base resistor spread. So since that is going to be reducing this particular QCE and QB charges across the device, this particular reduction will be continued up to the all the charges across this QC and QB will be getting reduced. So up to this, the storage time will be maintained. So this charge removal of the QCB and QCE and QB, these three charges are going to be getting reduced along this particular storage time. So this is the first time period of the turn off process. But still the particular charges which are not being removed fully, some of the trapping charges will also be available. So that trapped charges are going to be by the negative current removed by the negative ICE current. Since this particular current is going to be flown inside the material by the negative VBE which is got in the storage time itself. So since this VM minus VBE will be going to the constitution of this particular negative ICE, so the trapped charges will be getting expelled from the device. So the total turn off process will be consisting of two periods. One is going to be the storage period that we have mentioned here as TS. So TS is going to be the storage period or storage time, and TF is going to be the fall time. So this in this fall time, we will be having this trapped charges to be getting reduced by the negative current of the ICE. Okay, so this is how the turn off characteristics of the power BJT will be constituted.